Howdy, we'd like to welcome everyone to this first edition of the RSC Mechanochemistry Showcase. I'm James Batteas.
And I am Tomislav Friščić. We are the co-editors-in-chief of a very exciting new journal of the Royal Society of Chemistry, RSC Mechanochemistry. And it's not only James and I today, we are also joined here online and by video with several other editorial board members of this journal. And that includes Professor Guan Wu, who is joining us from China, Professor James Mack, and Professor Eddie Taiso, and Hajime Ito, and Professor Kirsten Blanc, who are joining us on video, as well as Professor Francesca Emmerling, who is joining us live from Berlin, Germany. Maybe before we kickstart this showcase, maybe we could say a few words about what this journal is all about. It is actually the first journal dedicated to mechanochemistry, and we are very excited about growing it together with the authors and colleagues into a forum where all sorts of things related to mechanochemistry can be discussed and reported. Mechanochemistry is a very broad area, and we do want to make sure that everybody in this area is included and contributes to the growth of this journal and of the field. It is, as I mentioned, the only journal dedicated to mechanochemistry. It is also created by mechanochemists. In this journal, the work is being edited and it's being reviewed by experts in the field of mechanochemistry, coming both from academia and industry. And we all want to come together and find out and establish where is mechanochemistry today, where does mechanochemistry come from, where are these roots, and also where is chemistry going to be in the future, what is going to be its role in the future of chemistry, technology, very broadly. If you wish to publish in the journal RSC Mechanochemistry, which I think is actually a great choice if you are a mechanochemist, the journal is just started very recently. The first papers were published just this year in March. Papers, once they're accepted, they appear immediately online, and also full issues get compiled and published every 2 months. Did I forget anything, James?
Well, I think it's good to also emphasize that, mechanochemistry is fantastic. Mechanochemistry is where chemistry and mechanics meet, where forces acting on molecules conspire to drive chemical reactions. And another key goal of our journal is to bring together the broad range of disciplines in which mechanochemistry plays such a central role and help bridge the knowledge gaps between them. So I think it's going to be a fantastic opportunity for this.
There is, well, in my experience, there is a ton of exciting new things one can do with mechanochemistry. One thing that's really emerging across all areas is that mechanochemistry is surely going to play a very critical, I would say even a central role in sustainable and scalable chemical synthesis. It's probably going to have a very, very strong impact across all areas of chemical manufacturing, actually.
No, I agree. And, today we're pleased to be sharing with you, the audience, showcasing some of the first articles published in RSC Mechanochemistry as selected, presented by members of our editorial board. So first, we have James Mack, one of our editorial board members based in the US at the University of Cincinnati. And while James can't join us today, he sent in a video sharing a paper that he selected to showcase in this event. It's rather unique, and I'm going to now hand it over to James to tell us more about it.
My favorite article so far in RSC Mechanochemistry is an article by Martini and co-workers called "What Makes Every Work Perfect is Cooking and Grinding: The Ancient Roots of Mechanochemistry." The reason why this is my favorite so far is because this is an article that really brings us back to our roots as it relates to the fact that mechanochemistry is not a new technology, but actually a quite old one. It's one that really was originally done in a lot of places. And here, these authors reproduces work that wasn't done last year, but work that was done many centuries ago, going back to the 3rd and 4th century, and digging up some of the experimental procedures that were done back then. Many mechanochemists know of the work in terms of creating cinnabar from mercury and sulfur, and Martini and co-workers tried to recreate that through modern technology, no differently what we do when we're trying to reproduce any type of experiments. They use XRPD to determine that they were able to reproduce some of the results, but it really wasn't the results that intrigued me. It's the idea that we can do mechanochemistry, and we've been doing mechanochemistry for a long period of time. And I think about how far along we could have been if we consistently stayed with mechanochemistry instead of shelving it away for other methodologies. So that's the reason why it's my favorite. And I hope to see more work like this in the future.
Well, I hope that you have enjoyed this overview provided by James. It definitely is a very interesting paper, and I would like to invite you all to go online to the RSC Mechanochemistry website and definitely read it. And if you find it interesting, you may even, I don't know, you may even find it useful in your research. But we got more coming today. And the next here on our roster is, I'm very proud to introduce Professor Guan Wu, who is joining us, as I mentioned, from the University of Science and Technology in China. It is actually pretty late right now in his time zone, so thank you once again, Guan Wu, for joining us and doing this live with us for the journal here. He is now going to highlight what he finds to be an exciting and interesting RSC Mechanochemistry recent paper. Without further ado, over to you, Guan Wu.
Hi everyone, I'm Guan Wu from China. Editorial board member of RSC Mechanochemistry. One of my research interests is mechanochemical organic synthesis. Until now, the mechanochemical synthesis of active pharmaceutical ingredients, APIs, is relatively rare. Today, I will showcase an advanced article by Professor Jinbo Yu, Professor Weike Su, and co-workers from Zhejiang University of Technology. This paper was selected to feature the mechano-synthesis of a pivotal intermediate of Pitavastatin, that is PTV, an important cholesterol-lowering drug. The three-step mechano-synthesis involved Suzuki-Miyawara coupling, midi-CK-CH alkylation, and oxidative Heck carbon reactions. In this study, the author emphasized both bore mini and twin screw extrusion technology. It should be emphasized that in the bore mini midi-CK reaction step, a wide range of cell heteroarrays and even bioactive molecules like caffeine, theophylline, and cryoquinol could be used, demonstrating the potential of the later stage modification of drug-relevant molecules and natural products. In conclusion, this paper demonstrates the eco-friendliness and the scalability of both bore mini and continuous flow extrusion technology, and the successful application to the synthesis of key intermediate of a drug molecule. This work serves as a good example in advancing green chemistry and the potential in pharmaceutical engineering. Thank you very much for your kind attention.
All right, so thank you, Guan Wu. That was great. Up next, we have Professor Eddie Taiso from the University of Wisconsin, Milwaukee in the US. And he's going to share his thoughts on being an editorial board member and joining a new journal such as RSC Mechanochemistry. And so now let's hear from Eddie.
Hello, my name is Eddie Tyso. I'm very excited to be on the editorial board of this new journal, RSC Mechanochemistry. My background is in physical chemistry and understanding processes occurring on surfaces. And I did my PhD in Cambridge with Richard Lambert to look at the mechanisms of surface catalytic reactions in ultra-high vacuum. I then moved to work with Gabor Somogyi at the University of California, Berkeley, where I worked on high pressure reactions and tried to bridge the pressure gap between fundamental studies in ultra-high vacuum and catalytic processes occurring at high pressures. When I moved to the University of Wisconsin-Milwaukee, I, among other things, started to look at the way in which sliding interfaces, forces could affect reactions on surfaces, in part because I had a PhD student who worked for a local manufacturer of lubricants who was interested in learning how they worked, and he got me interested in this field. As part of that progression with Nick Spencer at the ETH in Zurich, we founded a journal whose goal was to look at the fundamentals of tribology, tribochemistry and other areas of tribology at a fundamental level called Tribology Letters. So I have some experience of the pitfalls and challenges involved with setting up a new journal that I hope to be able to transfer to RSC Mechanochemistry and help it to be successful. I think the challenges that we faced at those early times are different to the ones now, because we've learned, I think, more about the way in which stresses affect mechanochemical processes. But I think the challenges remain, and that is the difficulty of studying solid-solid sliding interfaces at a fundamental level and getting mechanistic information of what the reaction pathways are and using those models to describe those reaction rates. So I think the challenges, in addition, of course, to the synthetics challenges of making new molecules, will also lie in developing analytical methods that give us good reaction rates on well-defined systems and developing the models that describe those accurately. And I look forward to working with the community to try to accomplish that.
Well, I don't know about you, but I found it really interesting to hear Eddie's views and on this journal and its significance in the future. And now we are going back to talk about some more papers published in RSC Mechanochemistry. And it is my greatest pleasure to introduce a very established mechanochemist and an excellent colleague, Professor Francesca Emmerling, who is joining us from the Federal Institute for Materials Research and Testing in Germany, also known as BAM Berlin. Guten Tag, Francesca. Francesca is one of the editorial board members who actually handles the manuscript. So if you ever submit your paper to RSC Mechanochemistry, she may be your handling editor. Francesca has been so kind to join us live, and without further ado, it's on you, Francesca.
Yeah, thank you very much, Tomislav, for the kind introduction. Thank you for having me live. I'm really bad in recording, so that's why live is maybe much better. So I'm pleased to be around today and discuss amazing science already published within RSC Mechanochemistry, and I'm hoping for great science coming along. So send in those manuscripts. I'm desperately waiting for new ones in my box. So my background is in solid state chemistry, and then you might realize why I chose the paper I chose today. I've been in the field of mechanochemistry for around about maybe 15 years, and my group is particularly interested in understanding kinetics and a mechanism behind the mechanochemical process. So we do lots of in situ investigations, keeping in mind that we, in the end, want to upscale processes and also understand them to make them reproducible. So yeah, we look into different kinds of materials. It can be in the field of pharmaceuticals, but also framework materials, mostly with the idea of energy transfer and storage. And energy storage brings me smoothly to batteries and the paper I present today. It is about recycling of lithium from lithium iron phosphate batteries. And the paper was published by the group around Helmut Ehrenberg from Karlsruhe Institute for Technology, the KIT. And in their paper, they discussed how we can make use of mechanochemistry to recover lithium from lithium iron phosphate batteries. We all know that lithium ion batteries are around everywhere in our mobile phones, but also in the vehicles we drive. And also at my own institute, there's a huge focus on recovery, but also safe storage of energy. So nevertheless, we need the materials back. They cannot end in landfills, and therefore we need new methods to recover them. And here mechanochemistry comes in. And I like especially in this paper that it connects a sustainable method with the sustainable purpose. So it has a double check-in on my list. So the colleagues used, in this case, aluminium as a reducing agent, and then they milled lithium iron phosphate for different time spans, and they were able to discover the mechanisms of what's really going on during the progress. So they could monitor different species that are formed intermittently and also explain what we get in the end. And they really managed to discover a huge amount of lithium in the form of lithium carbonate in the end. This paper is specifically strong because they also used different analytical techniques, solid state techniques, to really understand the processes. They did not only rely on X-ray diffraction, but also X-ray absorption spectroscopy and also Mössbauer spectroscopy to really understand which phases we have present in the end. So there's still a lot of work up, but I think the initial step is done, and I'm looking forward to many more papers of this group in also our journal. Thank you.
All right, thank you, Francesca. That's a great. I definitely enjoyed reading that article as well. It's really an exciting paper. So next up, we're going to hear from Professor Hajime Ito from Hokkaido University in Japan. Professor Ito is another of our handling editors, and he has selected an article from Professor Otsuka and co-workers focused on polymer mechanochemistry. Professor Ito was particularly interested in this paper as it shares a very rare synthetic example of luminescent radicals, and it was the first example of these to be generated by mechanochemical methods. And so we're going to now let Professor Ito tell everyone more about this exciting work.
Ball milling of polymers such as polystyrene produces mechanoradicals by cleaving the main chain of the polymer. Otsuka and co-workers used this to generate diallylacetonitrile radical, a luminescent radical by ball milling the solid polystyrene powder and radical precursor. Diallylacetonitrile radicals are usually unstable, but in this method, because the fluorescent molecules are dispersed in the polymer, they are stable enough to be measured for the luminescence properties. It was also found that the emission wavelengths can be changed depending on the structure of the precursor.
Well, that was very exciting. Thank you very much, Hajime, for your video. And last but not least, we would like to conclude the showcase with again, a video contribution from one of our editorial board members, which is going to be Professor Kerstin Blanc, who is currently a head of department at the Department of Biomolecular and Self-Organizing Systems at Johannes Kepler University. Ready for the video?
I'm Kerstin Blanc from Johannes Kepler University in Linz in Austria, and I would like to introduce a more biologically oriented paper from the group of Muhammad Mofrad at UC Berkeley. The paper deals with a mechanochemical question in biology. It investigates the role of a specific protein in chromatin cross-linking in the nucleus of mammalian cells. In principle, we can imagine chromatin as a polymer network with cross-linking units. These determine both the mechanical properties of the chromatin network as well as its ability to undergo liquid-liquid phase separation. It has been observed in experiments that the chromatin network is compacted upon force application, but the molecular mechanisms behind this response remain unclear. The paper probes the role of a specific protein, heterochromatin protein 1 alpha, in force-induced chromatin compaction. Using molecular dynamic simulations, it investigates the stability of dimers in the presence and absence of force. The simulations show that the protein undergoes a conformational change at the dimer interface. This in turn leads to a change in side chain orientation of charged amino acids, resulting in strengthening of a salt bridge. You can see this in the graph at the bottom, where the distance between a lysine and a glutamic acid becomes shorter when the force is applied. This is a highly interesting observation. It could mean that this protein dimer forms a catch bond that becomes stronger under load, and this opens up new questions for experiments. This paper is thus a very nice example showing how molecular insights can explain the macroscopic behavior of a material. It would be really great if such principles can also be applied to synthetic polymer materials.
Well, that's it. That concludes the session today, at least relating to the article highlights. With this, I would like to once again please invite you to come and visit the journal website, check out the articles, read them in full and carefully, and also read all the latest developments in mechanochemistry. Thank you for joining us. James.
Yeah, I think, and before we close out today, we also want to highlight and had to give a shout out to a few of our other editorial board members who weren't able to join us today. Lars Borchardt, who is an inorganic chemist based in Germany, is an expert in mechanistic principles underlying diverse mechanochemical processes, as well as devising innovative setups for scale-up. He's also on our editorial board. And Tomislav?
Yes, and also the third associate editor who is handling manuscripts for the journal is Professor Evelina Colacino, based at the University of Montpellier in France. Professor Colacino is an established researcher, particularly focusing on environmentally friendly uses of mechanochemistry for industry, and in particular for scaling up and sustainable manufacturing of pharmaceuticals.
And then further highlighting the broad reach of mechanochemistry, we're also joined on the board by Professor Jeffrey Moore at the University of Illinois at Urbana-Champaign in the US, and brings his expertise to the board with regards to polymer mechanochemistry.
And, well, with all the showcases today, I think we have seen quite a breadth of topics, from inorganic materials to pharmaceuticals to biologically relevant systems. And we also want to pay attention that we engage industrial audiences and industrial applications. And in that context, we just want to highlight also another board member, which is Dr. Maria Elena Rivas Velasco, who joins the journal from the aspect of industry, specifically Johnson Matthey, and being based in the UK, with expertise in inorganic materials, especially in the context of automotive and energy and specialty chemicals markets. But again, these are just only a few of our many editorial board members. And if you want to see who else is involved and what they're up to, again, please come and check out our website and see it.
All right. And with that, we just want to conclude by thanking everyone who's been watching today. And would like to encourage everyone to reach out to us with your ideas for the journal. If you have ideas you want to share with us in regards to review articles, perspectives, or other new things that you want to help highlight in the exciting area of mechanochemistry, please don't hesitate to contact us. And as always, please keep checking out the journal and follow us on LinkedIn, and we look forward to speaking with everyone soon.
Thank you for joining us. Have a great day.
Bye.